and we summed up the slices. Only now you're going to do it for these forces times these distances. So second paragraph, page 490. You've got an object moving along a straight line from A to B. By A, now this is a little bit goofy too, continuously varying force. So I'm telling you that it's not, it's going to be, I might be pushing harder and harder, but it's going to be a continuous push if you want to think about the force being a push. Okay?
Oh, not that it's varying continuously?
No, the force
That the force changes, the graph of it is going to be continuous. So it might be increasing, but it's not going to be 50 pounds and then 100 pounds. It's going to increase continuously or decrease continuously. So there is that little catchphrase inside there, continuously varying force. So we're going to have a function to describe what this force is doing. Okay, so let delta, you know, that's that symbol, the triangle. Let delta be a partition that divides the interval into n subintervals, where you let A, that's the first coordinate, correspond to x naught, and you let B correspond to x sub n. So we've taken a little number line, we've divided it into n little pieces, and we label them x naught, x1, x2, dot, 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 until we get down here to x sub n being at B. And what we're going to do is take little snapshots. And if I take a little snapshot, the work done within one of these little pieces is force times distance. So then if I take all those little force times distance partitions and sum them up, I get that little summation you see, sum I equals 1 to n, f of ci delta x sub I, so that's force times the little distance on that subinterval. And if I let the norm of the partition, that's those absolute value, the double absolute value bars, that's the norm, approach 0. That's the same thing as letting this get smaller and smaller and smaller. So you really take the largest subinterval, we let it approach 0, and that's going to make all of these approach 0, and that's a Riemann sum. And once you have a Riemann sum, when you take the limit, that's an integral. So what happens when it's a continuously varying force, we end up with this for our formula. Integral from A to B of f of x dx.
Looks a lot nicer.
Yeah, yeah. Now the homework has some problems involving physics laws. And one of the physics